All right, I'm going. So please accept recording. So I should start so early. All right. Nonetheless, we will. How many persons are here now? 5. Mhm. Still coming in. All right. For the inertia, it's 1 upon 36 b h cubed, right? And that's how you find it for the triangle. And for the circle, you find the area, and respective whether or not you find it for the x-axis or the y-axis, you will use, if it's x-axis is 1/8 pi r to the fourth and all of that. And this is given. So, and this is the same thing for a circle. Circle is a quarter, right? And so on. All right. So last time we had looked at this figure. I just want to do a recap. Just to ensure that you are following. So it says complete the parallel axis theory. So we remember we use the parallel axis theory. First, you use the formula, the standard formula, but then now you're going to have to consider, is it a full circle? So in this circle here, I'm trying to find the figure. So this here now, right, let me see if I get the standard one. So here now you will have a circle in this one, and if you notice carefully, this is the x-axis, right? I didn't show you where the y-axis is. So you just finding it in terms of the x-axis. So they say you must compute the inertia but compute the area respect to the x-axis. So you have a cutout section here, right? So you draw a regular circle and you draw a regular rectangle. But of course, in though it's a rectangle, we consider it have breadth and we consider it have height, right? And the height here is 150 millimeter. All right, so when we separate it into two parts, all right? So let's proceed to the next slide. Okay, so right away, we are able now to use the parallel axis theorem, right? Your reference axis is the x-axis. So right where the center is, that is 75, right? From the x-axis. So the standard thing is to use Ix prime would mean that you use a standard formula for a circle. And the standard formula for a circle for inertia is 1/4 pi to r to the fourth power, right? All right, after you have done that now, you will have to go to the parallel axis theorem. So the parallel axis theorem says that area, which the area of it is pi r square, right? So the area is pi r square. And of course, you need to find dy. So dy is going to be the distance from here to this point. That's the distance from the x-axis, right? X-axis to here. And of such, you know you square that parameter. So that is 75 square. All right, let's move on. Any clarification? Anybody have any questions so far? Anything? Yes? No? Anyone? No one? All right, let's move on. So, okay, let's move on to this one now. Just remind you. So you go back again and you want to find in respect to the x-axis. And of course, you know when you find in respect to the x-axis, you're using y components, essentially, especially for the parallel axis section. Here now you're using the standard formula for rectangle. And for a rectangle, we know it was 1/12 b times h cubed. All right, but we're gonna show you that chart. You know, you find the area, which is here, length times height, or they have length times width. What is really length times height? Because it's the height we're dealing with here and here. And in some people will say the breadth and the depth. All right, same thing. And that, of course, would have been 100 times 150 for that section. And the parallel axis theorem from the x-axis to the center of the figure, always to the center of the figure, is 75 also. So you square the 75. All right, let's go to the next slide to see how it's developed. Slide not moving on. All right, so we go back to here, and it just showing you the what about the parallax theorem. So that just clarifying what we did already. So let's backtrack in a little bit. So here we are, here we go now. So right now, this one now shows it. This is a standard inertia for the circle, right? So it is 1/4 pi to the radius to the fourth. Now the radius of this is 25. So therefore is to the fourth power. All right. What about this section? Is the area, which is pi r square. So it's pi times 25 square times 75 now would be the distance between the center of it, right, onto the x-axis. So right there you have it. So this part gives you the parallaxes theory coming into being. So you do the first part of the inertia to the to the x prime axis. The x prime axis will be the axis up here. So you have, and this axis is parallel to this axis here. All right. So using the parallaxes theorem, we see that the inertia, and notice it's 10 to the 6 to the fourth power. Both of them, when you work them out, they're gonna get to the fourth power. Both section, and you simply had them together. Now you go ahead and you do this one again, just a recapping. So you go parallaxes theorem again. This is a standard inertia for the figure itself. Then you apply the parallaxes now in terms of this section, where it's going to be a distance from the center to here, which will give you dy, right? And you notice when you're finding it to the x-axis, you're using y components. Remember that. So what we're trying to do is find the distance from x, the reference axis, to the center of the figure, right? And of course, that is 75. And you square that, multiply by the area. And as I said before, you have length and width here, which that's the area of a rectangle. But if you see breadth times depth, mean multiplying to give you that, the same thing. But that's area of a rectangle is really length times width standard. All right, so let's move on. All right, so here we go. For the standard formula for this, for a rectangle, is going to be 1/12 breadth times the height. Now the height of it, of course, is going to be 150. So 150 cube, because that's the height cube, times 100, which represents the breadth down here. All right. Now, as you move on, you do the next part now. Where is the area now? This part here, A. So A is represented by 100 times 150. So that gives you this piece here. And the dy, we said was 75. So it's 75 square. So you had both of them. And then we see, let's move on to the next slide. Is there any clarification? Anybody clear on that? Anybody good with that? If you have any question, please ask now. All right, because the circle is a cutout section, it's not really a part of the figure. You are not going to add this inertia. You are going to subtract the inertia of the circle from the inertia of the rectangle. And as such, you would have subtracted them. Both of them are to the 10th power, and you'll get this value. Any question there? All right, now we're going to move to a different figure. So last week, we would have briefly looked at rectangular figures. I did give you an I-beam in class. I demonstrated an I-beam. I don't know if all of you catch it. I'll probably repeat it today again. So this is the figure that we have. And I want you to be careful. The figure that is being mapped out is this figure here. See if I can draw this thing straight. I'm just trying to. This is a line. This is a figure that we are looking at. In other words, it's a 3D representation. All right, and here we go with the line here. And of course, these are straight. I am just trying to trace it so that to help you. Now, here you can approach this in many ways. Once you have it in a rectangle, you will have to separate it into different segments or different parts. Right? So you pretty much, this is what you have here. So we're technically going to get 3 rectangles out of this figure to represent it. Now I won't divide it yet until we move to the next. So let's just recognize the measurement we have here. So we have 100 millimeter here for this thickness. while from here to up here is 400. But the thickness is 100. So that means that this distance here, we can see immediately that this is 300, right? And similarly, this one down here is 300 also, from here to here. So those are given, just looking at what we have. Now, if the distance from here to this side is 600, it means that this distance here, from here to here, is 500 millimeter. And of course, they are millimeter. Right? Must always put the dimension beside it. All right. And this, of course, we know is 100 right here. So see it here? Okay. All right. So let's look on how we approach it. The first thing you're going to do when you're finding inertia, you have to go back to the centroids. Right? So you say you must determine moment of inertia of the beam, cross-sectional area, and you know the cross-sectional area is a cut section, all of this section here, right? So the cut section across the X and Y centroidal axis. So firstly, they give us where C is, so we don't necessarily have to find because it's a given. Looks to me that it's right in the midway between both axes, right? Normally, for once it's given, you don't have to struggle to find it because you actually know where it lies, right in the center. If the thickness is 100, then we could say that this is 50 and that is 50. Let's look on it. Let's see what's the development based on the information given. Let's see what is given. All right. So here we have it. And it says, so everything is drawn out here now. Can show you more proportionally. We're gonna say that, so you see you have a red line here. So it's basically just giving you where the figure stop. You can see where your centroid is, right, clearly. All right, what do they say? They say you may use this question given X and Y axis as shown, but particularly for the moment of inertia question, you may be asked to work with an axis about the centroid. So you may be asked to work on an axis about the centroid, and that is true, right? Move on to this here. Simply determine the dimensions related to the centroidal axis, all right? So you must determine the relationship to the centroidal axis, all right? All right. As I said before, you normally separate, so get into the figure now. This is a figure that you're actually interested in. If you notice, it is separated into 3 parts. So you have segment A, which is all of this. So A is all of this right here. And you can clearly see that the height is 300 millimeter. The breadth here is 100, remember now. And for B now, the height is what? 100. And the breadth is 600, right? Is that 600? Let's just check that. Right, because from here, it was told from here to here is to the end was 600, right? If you recall that. So as a result, we see where A to the centroidal axis. So this is where C is, right here, where the centroid is at the center. And I remember telling you something about symmetrical cross section, that their thing is a little bit different when it is symmetrical for the symmetrical section. All right. All right. So it says identify the composite parts. All I mean that you must identify the section, divide it up into a section A, B, and D, or you could call it 1, 2, 3. But anything that you label it correctly, and you need to find. So the next step that we normally tell you is to find the area of each section. Let's move on. All right. Now, let's see if I can see this thing. It is, all right. So it says, apply the parallax theorem to rectangle A, right? And when you apply it to rectangle A, it says, remember, the question wants the moment of inertia about the X and Y centroidal plane. So you're going to find in respect to Ix, meaning you find in respect to the x-axis. But of course, I told you before you're using some y components. So this one would have been 1 upon 12 times bh cubed, right, plus a dy squared. So y here is because you're using y components. Essentially, you're using y components. All right, so let's look at a. In respect to the x-axis, and I'm not doing y-axis now. I'm going to leave that out for now. Just go to the x first, and then I'll come back to the y. All right, so for the a now, it would be what? 1 upon 12, because you're using the standard formula for rectangle, times the breadth times the height. Now, it's the height cube. So if you look over here, this is the height, which is 300, and this is the breadth. So right there, you put that section in. All right, the next step. Any question so far? The next step right here, you are going to do this section here where the area of it is going to be length and width. So it's going to be 100 times 300. So you have that section there. All right, finish. What about the dy? The dy, how did we get the dy again? The dy, right, it's now going to be a distance from where the centroidal axis is to the center of this figure. So if you look carefully, let's match it out. You would have had, this thickness here would have been 100. All right, but the entire length from here to here would have been 300. Remember, it was 600 going across. So that would have been 300 from here to there, 300 millimeter. I'm not gonna write that millimeter there, just that distance there. And of course, when you separate this, when you half of 100 is 50. So right here is 50 and right here is 50. Now, what you are left with here, so, and this distance was 150, because if it is 300, so 50 from 300, you're gonna get 250 between here and here, right? This is the distance you need, which is from here to the center. So this is, so it's 50 from 300, give you 250 here, right? Any question there? Did I make myself clear there? So all I'm saying, from the center here to halfway between here, well, this is 50-50, so it's going to be 50 from the 300, give you 250. And right there, right, so that would be, so what about the distance? But is the actual distance that you want in for this case, which is dy, let me go over that again. Your need what? The dy. So the dy will be a y distance from the center here. So let's from here. Let's check it out. I may have been looking at the wrong thing. So this is a figure. We want a distance to C. So this is the distance we want here. All right. How do we find that distance? We know that the complete height of this is 300. So it's halfway is 150, right? All right. And halfway of this is this full. The distance here is 100, but half of 100 is 50. So it's 50 plus this 150 here. Right. So let's get that. So that gives you dy. So let me clarify that. So it's 150 plus the 50. So that gives you the 200 that you have here. And then you will square the 200. All right. The other one that I was referring to is when you're doing it from the other axis. So let me not confuse. So this is what we're looking at. Let me just clarify myself. Put on back my glasses so I can see it. So here we have it. So this is a figure, and you want the dy. So the dy that you're interested in is this distance right here. From the center, where the central axis is, guys, remember the central axis is through here, right? So it's the distance you want from the center of that figure. Always, but this is a figure, that segment that you do is half of it, which is 150, plus the 50 here to the center of this, so it must be what? 200, right? So that is 200, all right? And therefore, you go, you want to work out this section, you will get 1.425 millimeters to the fourth times 10 to the, so it's really 10 to the 9 millimeters to the fourth. Right? Okay, you're gonna get a large figure for, in fact, what I think was happening here, this section need to be worked out separate, but you had both of them. So this is the final answer. If I was to work out the first part, let me tell you what you will have there. So you'll get 300, and some of you, your calculator, please practice doing it. So you're gonna have 300, and you put in the calculator, you're gonna get a very big figure, I can assure you that. Divided by 12. Let's see. All right. So let's see if this is correct. Let me check out that figure. I'm doing it in the calculator here. I'm gonna do it. Says 300 to the third power times 100 divided by 12. All right, let me see if I get the right figure here. So I'm getting a figure here. Let me see if I can get the engineer notation of this. You get a very large figure here. Let me see how big is this figure here. You're getting 2 to the 0.2. Well, I tell you, try and write out, let me see to how many figures this now. It's very fine. Let me see. That's 6. Look like 10 to the 8. 10 to the 8. Can somebody confirm that's what you got? Anybody? Anyone work it out? To the fourth? Hello, anybody? Could you all talk to me, please?
Yes, sir. That's what we got.
Mark? Could you?
Yes, sir.
Mark, did you work it out?
Yes, sir. Yes, sir.
Pardon me?
Yes.
What you got?
2.25 10 to the 8.
All right, and this one, oh, you're repeating everything. All right, what about the second part? Work out the second part. Tell me what you got for that. Tell me what you're getting for the second part. So 100 times 300, right, times 200 to the square. What you got for that part? Oh, where what you got for that part? I'm getting a pretty big figure. I'm checking this figure to see if this figure is correct. Time 10 to the, what's that? 10 to the 9. Let me just check how many figure, how many zero I'm seeing there.
1.2 10 to the 9.
Right. So let's add both of them. And let's see. I see A here as answer is 1.42. Just confirming that that is correct. So it's to the 9. So let's add the 2.25 10 to the 8. And let's see what we get. So we get the same answer. 1.425 times 10 to the 9. So that gives you, so you sum them, and let me put in the units here. Always try and remember to put in the units, 10 to the 4th, to the 4th power. All right. So that one is pretty much for the x-axis. So let's do the next one for the x-axis. And let's go again. All right, let's go to the next one. All right. What about this one here now? Let's do for this, for the B section. All right. So for the B, all right, for the B here, the B is this section here. Right here. That section there. All right. So for the B, just going back over it again, using the same parallax theorem, which this is going to be 1 upon 12 B H cube times A dy squared. But this is all for B section, right? All right. So when you look at the B section here, your breadth is 600 and that height there is 100. So of course it gives you this section here. All right. Okay. Can somebody tell me why is it that we don't have this part here in it? Because we're not seeing that section added to it. Why is that so? Because when you remember now, where is the center of the figure? This is the central point. The center of the figure is here, which is what? At what? 300. So from here to the end of the figure is 300. But guess what? Where does the central axis? So remember, your D is going to be a distance that is between the central axis and the center of that beam. It so happens that both of them end up to be the same. So the center of this figure B is right here, and the central axis is right here. So it is symmetrical. So therefore, it means that your dy in this instant is dy square is going to be 0. So as a result, that section, this section here goes to 0. Right? And if it goes to 0, then it only leaves you with the first section alone. So it's 1 upon 12, 600 times 100 cubed, which is 0.05 times 10 to the 9 millimeters. All right, so that is how they got that. And let's do the other section and then I'll come back again. All right, so now we're going to do section D. Right, so just recapping here. Section D, again, reinforcing for those who didn't understand before. So section D, same thing happen again. This section is 1 upon 12 times BH cube. I tend to write in D, you know, because I used to write D. Nonetheless, doesn't matter. Same thing, right? All right, so let's go. So here you put in the standard again. So your breadth now is 100 and your height is 300. So you get this part straight off. All right. What about the area? We know the area already is 100 times 300. So that is a given, right? What about the 200? Right? So for the 200, it is similar. So 200 here, similar to up here, pretty much similar. So it's going to be, again, this distance here. See it here? Now the halfway is one is the entire height is 300. So half of 300 is 150. But also this distance right here is 50. So it's 150 plus 50, you'll get the 200. So it's 200 square. And so when you work out both sides again, we get back the same figure. It's the same thing because it is symmetrical. All right. All right. Let's go back. Let's look at the Y now. We're going to look at the Y-axis now. And the Y-axis. So in other words, when you're finding it, it's like your line of sight. For the X, when you find it for the X-axis, you're technically it's like you're looking that way, so to speak. It's like you're looking that way. For this one now, you're going to for the X, for the Y-axis, finding it with respect to the Y-axis, you're going to be looking that way. So your line of sight is going to be that way. So let's go back and look at them quick. Right? So I think I separated them. So we're going to go right back to 8. So down here now, we're going to focus on down here. This one here. All right. How did we get this? So it's the same thing. Remember now? Same thing like before. Let me clean up this figure here, see if I can get you to understand what I'm talking about. So I'm going to clean up this. All right. Come again now. Let's look at the figure. This is the figure that we are looking at. Let's move all of that. Right. And we're not looking at anything up here again. We finish it up here. All right. So let's come back to what we have here. Wow, I'm coming. What has happened here a while ago? Well, okay. Trying to find the slide that I was at. Everything was gone for me. No, not here. Here. Okay. Trying to get that right. All right. So right now, we're gonna be looking in the Y direction. So it's like you're gonna look that way. Right? So this figure, I can't bring it any closer, but it's typically you're gonna look that side. All right, and you're looking this way. Looking that way now, first one A, you'll be looking at this section. So when you're looking this way, with your line of sight in the X direction, so your line of sight is really in the X direction. So essentially, you'll be using X components, all right, when you're doing the Y axis. So this is in reference to the Y axis. Remember, two different axes we're looking at now. So this is Y axis, right? Up here so was X axis in respect to the X axis. This is in respect to the Y axis. So you see where the Y axis is right here, but you're looking this way to the Y axis. Now, why am I saying all of that? Because your breadth and your height is going to change. So this figure here, symbolize it, is going to change. Right, so the values are going to shift around. So when you look that way, this now becomes your breadth, right? And this now becomes your height. Any clarification there? So the formula in a sense is same formula, but only at different values. So your H is going to be 100 and your breadth is going to be 300 millimeters. So it switch around. So now you're going to have your B as 300 and your H as 100. So it's shift around. All right. So that you have found the standard part. What about the other part? So the area will remain the same for both, whether X or Y, that will be the same. What about the dx? Because you're finding the dx. So your dx now, right? Your dx, you're going to be looking for a distance here from the center to the center of this distance here. So this is the dx. How did we get that dx? Because as I told you before, halfway is 300, but half of 100 is 50. So it's 50 from 300 and you get 250. So that's how we get our 250. And when you simply work out both of them, you get the answer. Let's run to the next one quickly. All right, and for this one here, so same thing applies. Of course, again, the dxy is 0 because the center for the middle ones, right? So because it's symmetrical, your dx symmetrical to the centroid, it's midway. So the central axis and the center of the figure itself coincide. So there's no dx for that one. Dx goes to 0 for that one. And as such, you just leave with this. So for this one now, this becomes your breadth in this case, and this becomes your height. So this becomes your H, and this becomes your B, sorry. So your breadth and your height. So they shift around. If you notice, it was 600 up here, it's 1000. It shift around down here. So it's 100, 600. So this is 600 Q because the entire this H here would have been 600. All right, let's run to the last one quickly, which is similar. So the last one, which is D, this is now become your breadth, and this become your height. So it is 300 versus 100. So your formula have switched around, right? Up there, your breadth and height was 100, 300, but down here, they are shifted. Same formula, but the values shift around because they have changed position based on the orientation. All right, and that's very, very important. All right, and of course your dx for this one is going to be the same 250 because you know already the centroid up to this part was 300, so 50 from that, and you get that. So that is good. All right, no clarification there. Everybody understand that? All right, good to go. All right, and all you have done now is just add up all three components to get your overall inertia for the section. For both of them, you just sum all of the inertias for the entire section. All right. All right. What about this one here? Did we go through this last week? Can anybody confirm? Yes or no?
No, sir.
Didn't go through this one. All right. So let's go through this one. All right. It says determine the moment of inertia of the beam's cross-sectional area with respect to the x prime axis passing through the centroid of the cross-section where, and they give you the centroidal distance, the centroidal distance for y bar is 104.3. So they are saying to you that this distance from here is 104.3. All right. The fact that that is 104.3, so it's right here from the bottom of the figure down here, right? So it's a possibility. It didn't say, but a possibility this could have been your x-axis down here, right? Once you have x prime, then your x-axis is somewhere down here. So its possibility is right down here. Look, pretty much that it's down there, somewhere distant, some distant down there, right? They don't tell us where y would be. They didn't make reference to y, because y could either be here to the center, it could be out here. But we're not finding x bar. That would be relevant when you're finding x bar. In this case, they give you a value and say you have to work with it. All right, what do we have over here? It says, let the top circle be segment 1. So we're gonna call up the top here, top circle, segment 1, and the rectangle segment, right? We're gonna approximate this to a rectangle, right? So, and it's going to be segment 2. So this is 2, all of this here. Right, so they approximate it, even though you still have a little curve, we approximate it to a rectangle, right? So that is 2, this is 1, and then this is segment 3, right? And above this is the central position of each segment relative to the x prime axis. So what we're going to do now, in order to find your dy's, you are going to do it in relation to the centroidal axis and to the base. And we're going to call the base of the figure, we're going to consider that as x. So I'm going to just, it never said, but I'm just going to consider that x. Let me clean up this thing here. Right, I'm going to consider that x. So now we're going to stroll on to show you how to work this problem. All right. So, all right, let's look now. So we need, for each section, you're going to need to find a dy. In respect to each section, you need to find dy for, what's that, for the rectangle? All right, so for the rectangle section, let's look on how they find dy for the rectangle section. Remember I tell you that, so I'm gonna call down here my x-axis, meaning that I'm using this as my datum point. All right, all right, and up top here you have a top, right? You can choose to use, you can, in terms of your dy, you know, some figures you can work from top to the bottom and so forth, right? You can either work from up here or you work from at the extreme bottom. It's either one side, either up here or at the bottom you work from in order to find your dy. Depends on your approach, because you can have different approaches, right? Because I mean, I could say from the top to here, so it's my central axis, and I could say from the bottom to up here is my central axis. Well, most time we use, so it actually tell you from the base of it is here. So your centroidal distance from the top to here would have been different. It would have been different, meaning that you would have to subtract this amount from the total height of the figure to get it from the top. All right, but we are working from the base in this one. All right, and it's now the rectangle section that we are focusing on. So we're just focusing on just this little section here, coming up here, right? So let's look on how they approach. So the first thing for the rectangle, the height of it is 150. So that means the center of it is 75. Wherever 75 drops, that's the center of it. All right, that's the most important. Now, they told you already that your C is right here, which is what? 104.3. Okay. Now, the center between the rectangle and the centroidal point is different, right? And this can be demonstrated. So the center of the rectangle is at this point. But the central point is this mark down here, which is block that. All right, so I won't touch that. Now, all right. So the distance between, first thing you need to establish, couple things you need to establish. What is the distance between the center of the figure to the base where the x-axis is? So the center, if you work it out carefully, you'll find that from here to here is 75, but from here to down here is 50. So it's going to be, have to have 75 plus 50, which gives you 125 millimeter. Everybody agree with that? Two persons in the waiting room. Let me let them in. All right. Sorry about that. Let's move on. All right. If you see anybody in the waiting room and I have them acknowledge them, please say it to me. Thank you. All right. So here now, the distance between that now, so the central distance up to this point here where it's black is 104. So see it here? So the line coming up here, up to this point is 104. So you're going to have to subtract 104 from this because remember, it is this little distance that we are interested in. The distance between the central axis and the center of the figure. So that is a dy that we are interested in for that one. So clearly, we know that this is the value that we need for our dy when working the problem. All right, let's move on to another section. We're doing them separately. Another one now, we want the dy for the top circle. The top circle is 35, right, millimeter in what? Diameter. Right, so you'll have to say that you have a radius of 17.5, which is halfway. All right, so that is the height of it. Now, okay, so the center of it is halfway is 17.5, right? And that is the distance. So the distance from, all right, so most importantly, we need to establish from the center of this figure here to the base, what is the total distance? All right, so the total distance, we need to also know the total distance of, from top to bottom, it's going to be, well, let's look at it. 35 plus 150 plus 50, that gives you an overall height of 235. That's firstly. All right, you now need to find a distance between where the center of this figure in relation to the central axis. So you need to that's what we really need to figure out. All right. So if you look carefully, the distance from the top to the central axis is going to be, from the top of it, is going to be 235 minus 0.4.3. Right? Right. So you are seeing that so from the base you have 130.7. So we are saying that that is the distance, right, from the top to right here for that section. So it's 130.7 from the top of a figure to the centroid is that so that is your d, that is your d from the top. Of course, that's not dy, that's right. Now this fact that you have this distance up here, because some people can't see it, right? This is not the answer. This is just from the top. But remember, it must always come from the center of the figure. The difference between this, taking it from the center here down to here, is going to be 17.5 from that. So everybody have any questions? So this distance, see it over here, there's 130.7 minus 17. So it's always from the center of the figure to the central axis. So that is the dy from that. Everybody clear? Any question? Any question? Class, don't be afraid to ask question, and I want to know that you are with me. And we're talking the line all the way. Right? I want to know that you're okay. All right.
Yeah, look away, Stu.
Pardon me?
I said, look away.
So now what? Hello? I didn't hear that. Could you type?
Continue, sir. Continue.
Continue. Okay. All right, fine. So there now we find our dy. So our dy is actually this distance here. So it's from the center to the centroidal point, right? All right. So the rotation they tend to bend around that point. All right. Let's find the one for the bottom. All right. So the bottom circle here, circle at the bottom here is a diameter of 50, a radius of 25, of course. And where's your central point here? So you want some distance here now. Let's look for your dy. So from here, coming down now is 104 to right down to the where we call it the datum point down there at the bottom. But halfway up here, so it's 25, right? So we need to find that distance between where the center, where this is. This is distance we need, the center to right here. We know that this was what? What did we know from here? We pretty much know that, all right, you can work it out several ways. You can work out first the distance from here to down here, all right? And what was that? We know that already. That was given 104. All right. We know also that this is 50. All right. So it's 50 from this. You're going to get what? 54.3. Right. But you're going to have to also add the 25. Right, because you need that. You need the total distance from here to here. Right. So let's see if you understand that again. Let's go with that. So the distance that we want, this is another way to look at it. This is 104, 104.3, right? Another way to look at it, let's see, if you were to take 25 from it, let's see, if you were to take 25 from the centroidal distance, you will get 104. Let me see, it's not on the slide here. 104.3 minus 25, and you will get the same answer. So let's see if you understand what I'm saying. So this distance right here you need, right? But guess what? This distance, you need that distance. You need that dy. But you know that from base to down here, so it's 25. And you know the total height from up here is 104.5. All you have to do is take the 25 from that distance, and obviously this distance will come to you. So that is how I would say to you. I wouldn't use this approach that is on the slide necessarily, because it's kind of drawn out. So this one you can clearly see it. 25 from the center of this, because you know that this is halfway and it's 50. So all I would do, right, another way to look at it, a very simpler way, you need this distance here, which is right here. All I'm going to do is take away 25 from this distance here, which is 104.3. This one is a little detailed, this explanation. It doesn't wrong, it's not wrong. So all I did first, they took away the total distance of the circle from the centroidal distance. You got 54.35, which is representing the distance from here. But then now you want this distance from here, so then you have to go back and add this 25, which is right over. So that's another approach. All right. Let's run on to look at the problem solution. All right. So in order to do this problem, and we are doing it with respect to the x-axis. Respect to the x-axis, but you are using y components, so to speak. Right? So let's go again. All right. So here we have done. What time do we have? Is the first session gone? Almost finished. All right. So we have another person. No problem. All right. So segment 1 now is the top circle. And all of them, all you need to do as standard, you find the area of each section. So the area of this one, the one at the top would have been pi 170.5 square. Rectangle would have been 15 times, if you look back at the figures, so this would have been, the thickness would have been 15 times 150, right? But we don't have it here, looking at, right? And the circle would have been pi times the radius square, which is 17.5 for the top one. And the bottom one you just look at it was 25 square. So you get those areas and you have those. All right. We had worked out dy was for the top circle was 113.2 113.2 millimeter, and this one was 20.7, and the last one was 7. So you have those distance. Your first this one ix is going to be your standard of each one of them. So for a circle, it's going to be a quarter pi times the radius to the fourth. So you put in the radius of the circle, which was 17.5. So that gives you the first section. You have that. For the rectangles, I'm taking them line by line. For the rectangle, you have used your standard formula. Everybody remember the standard formula is 1 upon 12 b times h cubed, while this one was 1 upon 4 pi times r to the fourth. And right, and this one here is the same thing, 1 upon 4 pi times r to the fourth. So all you do for this one, the breadth, let's look back at the rectangle. You need to identify the breadth and the height. So for the rectangle, your breadth is 15 and your height is 150. All right. So there you have it. And this one is a given. Radius is 25. So you simply will have those values to work out, right? It's not in the table, but it's work out, and then now you're going to work out these individual sections. So all you're going to do to get AD square, you're going to recognize that this is D and this is A. You're going to work out that value and you multiply it by this value, and it, but this is D square, remember, and you put this value right here. So it is 12, so that would work out to 12.329 times 10 to the 6 for that value. You then move on to the rectangle now, and you do pretty much the same thing. So the area here, going to multiply by dy square. So you're going to square that term, right? And you're going to multiply it by this. Everybody good with that? So you get this value here, 0.964 times 10 to the 6. All right. After you have done that, you would have now had. All right, let's do the last one before I do it. So the next one is the bottom circle, right? So you're going to be pi times 25 squared. So that is the area times 79.3 square times this value, right? And you will get this section, this again. And see, that one was small and this one was bigger, so you get a little bit bigger. So it's 12.347 times 6. All right, all you're going to do next is add now. You're going to add this value here to this value, right? And you will get 12.402 times 10 to the 6. So this is the second part of the inertia, add to the first part. For each section, you do the same thing. So you work out that value here, which is not in the table, add it to this one, you'll get 5.183 times 10 to the 6. You do likewise this one here, I work out this value, add it to the ADY square based on the parallax theorem. So you get 3 values here now. And all you're simply going to do, you're going to sum all of the segment inertia. So inertia 1, inertia 2, inertia 3, and you get this pretty much formula here, 30.24 times 10 to the 6 millimeters to the 4th. All right. Any question? Good to go? All right. All right. Now we have a much trickier one we want to look at. All right. It's a little bit different from the others. Now, first you need to establish, you need to look where your X and Y axis is. So we have a section here, right? So we have a beam, right, shown. It says that now, right? The first thing that it said to us, it said the distant Y bar to the centroid of the beam's cross-sectional area. That's the first thing that they want. So they want this distant Y bar. So it's not given, they want that. And they want the second moment with respect to the x-axis. They also want it in respect to the y-axis. So it's two things that they want. They want it with respect to the x-axis, which we know first, and then to the y. So the first one, you'll be looking down here. You'll be down here. Where are we now? You'll be here. And you'll be looking that way. So you'll be only getting values that are in the y. For this, you'll be getting y using y component, and for the y-axis, you're using x component. All right. So they say the second moment is another way of saying moment of inertia. Note that for this problem, the y centroidal axis is already in place, right? And they have already estimated the position of the centroid, right? So it is estimated for y, right? Part one is asking for the position of x bar central axis. All right, so that's what they're clarifying. What is it that is asked up here, right? All right. Says now let us look at it. So we need y bar to the central axis of the beam. Now look what we have. So this figure, you would separate it into a number of parts. All right, so we could, if I was to draw a line, let me just separate it for you and show you how you separate something like this. Which color can I use? I want to use something different from what is up here. So, okay, so you separate it right along here. So all of this would have been 2. All of this would be 2. Coming right along here. All of this is 2. All of this is 2. Are you there with me, everybody? So that is 2. And up here now, all of this distance is 1. And if you notice, it's 2, 1 we have. 2 section that is 1. And it is symmetrical about the y-axis. All right? That's a very important thing. All right. And down here now we have from this distance, all of this distance come down here. This is the segment 3. So it's really separating it into 4 parts. 2 of them are similar, right? And they are symmetrical about the y-axis. And then you have 2, which is this distance here. All right, so clearly, we know right there now, we see where our central distance is up here that we are looking for. Now that you have separated into figures, first thing you'll go ahead and do, you go ahead and find the area of each segment. We know that segment 1 and 1 is the same, which is what? 100 times 25. So right, and it's 2 of them, right? So 100 times 25 is gonna give you 2,500 plus another 2,500 at 5,000 millimeters square, plus the entire length of this. What was the length of this? Now, so this was 25. So that gives you this is 150 here. Right from here to this side is another 150 plus the 25 here. So you're gonna get 325 for the entire distance going along here. And its width is 25. And likewise, this down here is similar to segment 1. I think this is 100 and this is, so actually segment 1 and 1 and 3 are similar, but they are at different locations, which will impact the problem itself. All right, let's jump to it. So segment 1, right? Segment 1 area is 25 times 100, which we said already. Segment 2 is 325 times 25, which is the thickness. Are the height, right? And the segment 3 is 25. So there's 2, segment 1 and 2 is the same, right? But remember that you're gonna have to double segment 1 because it's two of them. All right, so this formula that we have here, the y bar, let's look at finding the y bar for each section. So let's look how it is done for each section. All right, kind of a simpler approach. So for each section, in respect to the x-axis, so the x-axis is running right along here. So everybody see where the x-axis is? Let me draw, see if I can get a different color and show you where your x-axis is running. I want a different color, something totally different. So your x-axis is right here. See him running across here, green, to show it. Right. And then this is your y. Right, so the y, you know what the y is, would have been, your negative y will be dropping right through segment 3. Right? And this positive one is here, and then this is x. So, and this will be negative x, so to speak. All right, but it's just showing you where the axis lie. All right, so for the first one, from the center of this one here, right? Remember that this was separated, right? So for the center of this one, I probably even use a different color for that. Let me get a different color. Don't want it to be confused. Let me get a black or something. All right. So here, this is, that's a segment 1. Let's look at this segment 1 now. You need a distance from the center of this figure down here. How do we know that it is 75? We know that this distance is 100, firstly. All right, so let's think about it. So if this distance here is 100, that means there from the center of it to right here is going to be 50.
50.
That's the first thing. Then now we know that from here, this distance to down here where the x-axis is also 25. So it's going to be 50 plus 25, and that will give you 75. So that's how we get the 75 right here. So this is 50, this is 25, sorry, and this from here to here is the 50. So that gives you the 75. And likewise, the same thing over here, as they are symmetrical. What about the part, the segment 2? Segment 2 is assumed to be halfway. See, it's halfway this. Halfway, its centroid point is halfway, right? So it's halfway right here, which is half of 12, which is half of 25, pardon me, which is 12.5. So it's 12.5, which is right here, is halfway. This little distance here is what they're right? That little distance there is what they're concerned with. And for this one, it's similar. This distance here that you need to find it from is here. Where is that one? So this one here, halfway here is 50, right? So halfway through here is 50 for that part, right? So let's erase that. Everybody see that that is 50. We just clean it up. Take off some other stuff there. So that is 50. So it's from the x-axis to the center of it is 50. So you already everybody can clearly see that point. All right. Let's move on and look at what we have again. So we move on to the next slide. All right. So the next slide, we already know. We would have seen that dy. We didn't work out dy yet. Hold on. Oh, we had actually jumped the gun over there. Hold on. I was wondering what happened with the slide jump away from. So right, so that was 50. That is 50 from there. Actually realize that it changed it. That is 50 there. Halfway from here is 12.25. And for this one is 7.5. So we're gonna take it stage by stage. I think the slide jumped. All right, so for this one, we work out the area, which you would have worked out. And we saw that for the first segment, it was 75. The second one was 12.5. And the last one is minus 50. Can you show you where you get that minus 50 from? Minus 50, remember I told you that this was the y-axis, but this is below, is the negative side of the y-axis. So this is going to be not 50, but minus 50. Because it's here, so it's where you have your 0 point. right there. So it is minus 50 up to this point. So from right here to here is at minus 50. Let's go back and show that you understand that. So that is minus 50. All right. What you simply do, you're going to be multiplying these y bar by the area. So whatever area you work out to, and you multiply it, you will get this distance here. But this is to the 10 to the 3, time 10 to the 3. Right? If you see the bracket, it means time 10 to the 3. So it's 187.5 times 10 to the 3. If you want, you can confirm it now. Multiply 355, which is the area, 325, sorry, times 25, which is the area, times y bar, and it gives you 101.5625 times 10 to the 3, right? Similar, just using the y bar times a. And the same thing with this one, right? However, this is minus. So you know that this value is going to subtract from this. Remember now. So you subtract to get y bar here. Now, when you're working out, one of the things that you need to remember in your formula that segment one have 2 parts. Look, this is why we have 2 here. Because see here, it is 1 and 2. Right? So it's 2 parts. You have to double them, and they have equal areas there. So it's 2y1, right, for this one. So you'd have to double this value here. So this value here double by 2, plus this one here, which is ya2, this, right, this value here, plus the last one, right? Now you know that this one is going to be have a negative value, right? Because here it has a negative value there. So as I told you before, this actually going to be end up as a minus value there, right? So you're going to minus. So if you want, you could work it out. All that this is saying here, it will be 2 times 187.5 times 10 to the 3. That is that one. All right, guys, 2 of them. Then this one would be plus 101.5625 times 10 to the 3 minus 125 times 10 to the 3. Right? And that's supposed to give you 356. Can you all work it out and confirm for me, please? I'll wait until you work it out. Confirm it for me, please. I'm waiting. For those of you who just coming in, I'm expecting you to work it out. Hello, are you all there with me? Or are you just watching? It's not a movie, you know. I want you to actively participate to know whether or not you're understanding. Person with the iPhone, who is that, please? Someone have an iPhone there? Hello? Who's that person, please? It just says iPhone. I'm gonna ask you guys to label your thing when you come in. Do not just use your device. I will not let you in if you don't identify who you are. I don't know if it's somebody outside who is just coming in. Just please label your devices. I'm gonna stop letting persons who don't identify their devices. All right. Okay. Next. 20. For the last part there. Anybody go out and got that value there? Fender? Could you confirm it, please? I'm waiting for confirmation, please. Hello? Remember, this is a tutorial, you know. This is not a lecture that I should be here talking continuously and nobody interacting with me. Hello? Fender, are you there?
Yes, sir.
Right, so why are you not interacting with me? I'm calling you so many times.
No, sir, I'm saying I got the same value.
You got what?
I got the same value.
You got the same value. Okay, so you got 351.56 times 22. All right, that sound like I hope that's not an easy way to get rid of me from bothering you, you know. All right, I want you generally to try it. So this one, of course, you would have double the area again, plus this one here, 325 times 25, plus the last one, which is going to be, which is A3, right? So these are segment 1, as I told you already. You could call this A1, A2, A3. All right, so that is now your centroidal axis, right? Coming from the X. So okay, so your Y bar is 22.5. So let's look. So we can move on now to solve this other part of the problem. All right, so let's clean up the problem here because I would have messed up with it a little bit. Let's clean him up so that you can understand. All right, good. So we're good there. All right. Now, it says now you need to find the second moment. So we want to look at finding the second moment. We were told that our centroidal axis coming from the X to the center here, this is where C is 22.5. And that is very, very, very important to us. Now, the next move we need to make, we need to decide the distance between, so we want to find dy for each section. Can you label yourself, please? Galaxy S9. Please relabel yourself for me. I'm only saying to the last time, I've seen a lot of devices coming in and you're not labeling yourself. Right? You need to be labeled. Right? Okay. So remember I told you. All right. So here you go. You need to find, so the center of this, we would have worked it out already. That's to be 75. And the centroidal distance is 22.5. So it's going to be the distance between that. So it's 75 minus this is your dy1. Right? In respect to, I'm calling it d1 because segment 1. Right? That's why I'm calling it that. It's label it. So that is your dy. This distance we find here for the first one. What about this one here? So we know that from the x-axis to this point is 12.5, but we know that from the central axis is 22.5. So it must be the 12.5 minus the 22.5, which is what? 10. So this distance is 10 that we really want. See it here? So it is your dy2 is 10. Anybody didn't see that? So we're saying, remember your center C is this point here.
Sir, one more time.
Pardon me?
One more time, sir.
All right, so C, your centroidal axis point is this point right here. All right. Now, the figure that you want to find this the dy for is, let me see if I can draw that section. Remember this section, this is a segment 2 you want to know. Segment 2 is this little section here. Not even little section, all of this section here, coming down to here. That is segment 2. So segment 2, right? So segment 2, so you want to find this distance here from your, come again, from your center. Why is this thing changing it? From your center, let's go again and see if I can get in it. So from your center, hold on, let's see what's causing that. Let's see what causing that. All right, if I have a point, I may not move it. Okay, all right. So from here, whoops, wrong section, let's go. Trying to find back where we are. Right. Okay, we're right here. So remember now, your section that you deal with, segment 2, the thickness of segment 2, or the height, if you want to call it, is 25. Half of 25 is 12.2, 12.5, right? Now, so here, but the distance you want to find, remember that your centroidal axis is up here now. So it's the distance that you want is the distance between the centroidal point and the center of your figure. So the center of your figure is going to be here, which is, you know that this is 12.5 and that side is 12.5. You know the entire distance between the centroidal distance and here, which is 22.5. All of this is 22.5. So it means, therefore, in order to get that distance, you're just going to subtract 22.5 minus 12.5, and it will give you this distance here, this one right here. All right? Yes.
Did you explain how the distances are it says the distance for segment 2 is 25 right there where the
For two
is.
segment is 25.
For segment 2 is 25.
For the distance, yes, man, of course, because this
Yes,
is the height
sir,
there.
but it says from the x-axis down to segment 2 is 22.5. So what does that make sense?
It means, therefore, what it's really saying to you is that from the x-axis up to this point here is 22.5. This is where your centroidal axis lies, which is x prime. So when you work it out, and we did all the calculation, remember when we worked out, we got this 22.5 is just using the centroid information and the formula. Right? I didn't have to use the formula here, because basically what you have done here, you would have had this information here, but you couldn't just add it as is, because you would have to add all the segments. All the segments here are not accounted for now, because remember it's 2A1 you have. So you'll have to multiply that by 2, add this, and add all of everything. So multiply this by 2 and add everything here, you would get this value, which is 1.569, whatever that is. You get this big figure here down here, 15625. You'll get that value. Down here, it's similar. It's 2 of this you have, so you have to double this, add that value minus, and then you got this distance, right? So we're clear on that. As a result of that, it is showing you that you get a positive. Remember that the distance you get here is a positive 22.5, right? So that means it's above the x-axis. On the positive side of the y, you get a positive value for the y, which is 22.5. So from here, so where's your 0 point? Your 0 point is right here now. 0 is right there. Do you agree that your 0 point there, where your x and y meet? So that distance coming up to that point is 22.5. So all you're going to do is subtract. Remember now, the objective is that you need to find half of this distance, which is 25. So half of 25 is 12.5. You subtract 12.5 from this distance out here, which is a centroidal distance. You must get the axis that you tend to want to bend around or rotate around, right? That distance. So that is the distance you want. So you take away this 12.5 from the centroidal distance, and you must get this distance around it. So always you try to find the center of the figure, and then you subtract it from you try to see the distance to your centroidal axis. If the centroidal axis was below here, is the distance from here to wherever it is down here. And you take away the distance, which is half of this. You're always half of this distance from the centroidal distance. Right? So all I'm asking you to look at it is look at this distance down here that you need to subtract from the total 22.5 to get this distance, to get this value here, which is 10. Right? Is that clear now, sir?
Yes, sir.
All right, so let's move on. All right. All right, the next part is the segment 3. Segment 3, where is the centroidal axis? Up here again. We know that from here up to the top, where this centroidal axis is 22.5. Right? From X up to that point. And we also know that from the center of this figure to the x-axis here, so is 50, right? But we really want to find the distance between here up to this point. So the only thing you can do in this case, rather than subtracting, you're going to add. So you're going to add 50 to the 22.5 to get this total distance running down here. See it here? This distance running down here. So you're going to get 50 plus 22.5, which is give you 72.5 millimeter. Is that distance there. All right? Having done that, right? So let me go again. So having done that, you would have got your total, your distance from the center of the figure up to C. So that will give you your total value there, what? 72.5 millimeter for that distance down to here. All right. All right. So based on that, we now have all the dy's. So the dy3 for this one is 72.5 for the dy3 there. All right. So your dy3, all right. That's your dy3. Come on, right? So that's your dy3, right? And your dy2 is here, your dy1 is there. And from that now, we can formulate it into our expression here. So all you need to do here, you remember, so we'd have worked out all of these values here just now. All of these. You have your areas there, right? And then, so for this one now, you would have used the standard formula, which is what? 1/12 times breadth times H. I was gonna call it D. But this slide have H. I'm trying to be consistent. So that is B times H cube. All right, and you do that pretty much for all of them. So all of them, let's look back at them. For the first one, it would have been your breadth would have been what? Your breadth is 25, and your height is going to be, what was the height again? 100, right? And it's two of them you have. So let's look at it. So it's 25 times 100 cube for that one. And the next one, which is this big one here now, segment 2. So segment 2 running all the way here. Segment 2 is all of this. See there? So for segment 2, your breadth is going to be what? I think it was 600. And your height is 25. And for the third one, your breadth would be 25 and your height is going to be 100. So let's look at those. All right, so see you have them there. So your breadth for the segment 2 is 25, while your depth is 3. So this is your breadth and depth. Which one is this? This is IY. This is the correct one, I'm at. Let me show. Is it the correct one? Or is it's jump over? Oh, yeah, it's jump over to the wrong one. So this is for the x-axis. I was at the y-axis a while ago. So this is 325 times 25. 25 cube. Let me show you. So this is all of that. That's your breadth and your depth. So this is going to be 325 times 25 cube. Let's see if we get there. All right, so see there, 25 cube. All right, applying this very same formula. And for the next one, which is going to be, let's see if we can get back there. 25 times 100 cube. Let's look on that one. Where is it? So see there, 100 cube, 25 times 100 cube. Just applying your basic formula. The last section now, you're going to multiply your area times your d square, and you get this value here. And you do that for all of them. Area of this times dy square, and you get this value. This area again, which is the same thing up here, times this square. However, you must remember when you're adding this section here, there's 2 I sections. There is 4 sections in all. 2 of them are similar and 2 are different. So here you have to double this one. And you simply add them together and you will get this value right here. All right? It's as simple and as straightforward as that. All right. That is for the x-axis. All right. What about if you're doing the y-axis now? So for the y-axis, is there any question before I move on? Hello?
No, sir.
Any question before I move on to the y-axis?
No, sir.
All right. So the y-axis now, we're going to be looking at, so in effect, the y-axis gonna be a little bit different. You'll be looking this way. That's your line of sight. So you'll be looking that way. All right. So you'll be looking this way. All right. All right. So you'll be using x component this time around. So when you're doing it for the y-axis, you're looking for x component. All right. You're told one thing about the y-axis, that it is in the center of the figure and it makes the figure symmetrical. You're told that, you know. So that they're telling you that this half is equivalent to that half over there. You remember? Let me just show you about this slide and what it says. It says here, the second moment is another way of saying the moment of inertia. Note that this problem, the y centroidal axis is already in place, and they have already estimated the position of the centroid. C, part 1 is asking for the position of, all right, so let's show you what we're talking about. Let's jump to it. So we are saying they already estimate this. If we tell you that we know it already and it is symmetrical, looking in terms of the y-axis, what is half of this length here? What is half of this length? What is the length of the figure? Can somebody tell me what is half of this length here? What is half of that length? What is half of that length? So we want x bar. What is x bar?
162.5.
Pardon me?
162.5.
How much?
162.5
Yeah, same thing,
is the half.
162.5.
162.5. Because you have what? You have taken half of 325 divided by 2. Right? And you got that value. All right. I trust that value is correct. All right. So it therefore means that you look in this direction. We need now to determine our distance from the center to the centroid for each section. So from here, all right, this is, what was this distance given? The distance here given was that from here to, what distance did it give us? From here to here, we know is 162.5. All right, we are given that. But you also was told that up to this point is 50, right? All right, so we know that. So we can estimate something here. So if from here to here, all right, so 50 from this, I'm just trying to see how best to show you. 50 from this, what that would give you? Give you 112.5. Correct? Agree? So up to this point from here to here, it would be 112.5. All right. But you need to find the center of this figure. Remember, you had separated here. The center of this figure to here. So it means, therefore, this distance we want. How do we find that distance? We know that this is 25.
Negative 100.
Right, so 25, half of 25 is what? 12.5. So therefore, this distance from here to here must be this distance, 12.5. Subtract from that, give you 100. So so from the center here to right here, so them there are 100. If that is 100 there, then it's 100 over here to here, because it is symmetrical about the axis. All right, so that is one way of looking at it. Let me see if I can clean it up so you can see it, still visualize it. All right, so that's one way of looking at it. So the distance from center of here, right, we cut it right along here, right, halfway to here is 100. All right, that is what you need. So we know our distance, we know our x. What we want to call that now? We want to call that a x1. Our x2 is going to be what? The center of this figure to here is going to be 0. Our x2 is going to be 0. Why is x2 0? Can somebody tell me why our x2 is 0? And
It's on
and
the
our
x-axis.
x3 is also 0 too. Is our x3 0? Is our x3 0? So these two coincide, the center of this segment 2 and this point here, so coincide, right? So there's no distance from the center to this is 0. Also, this one is going to be what now? 0. So both x2 and x3 are all 0. Those are 0. Only x1, which is double, will have some value there. All right, so right, because you need to find the inertia. So you need to establish those things. And because of that, it makes the problem a little bit more simpler. As to, because it's given. So as a result of that, see them there, show that they are 0, 0. That is 0. That is 0, and only that is 100. All right. So all of this one now, you're just going to apply the standard formula, which is 1/12 BD cube. However, let me just step back here to show you that. Remember, I told you how you're going to look. Let's look to let's see if you are looking the right way. All right. So
Wait, the one question is
pardon me?
a question.
Mm-hmm.
How is x bar 3 0 again? It's below the x-axis.
Oh, what?
How x bar 3 is equal to 0? Is it under the
All right.
x-axis?
No, but remember. All right. I shouldn't call them, it's not x bar, I should really call them, it's x1 or x, it's not x bar, it's x3, x2 and x3. So in terms of my symbol there, let me just clean that up. I'm gonna rewrite the statement for. I want to tell you, let me rewrite that so that there's no ambiguity. So I'm saying x2 and x3 is 0. How did I come by that? Because when you have this section here, its center is here. But what is this? And you know that this section is what? It's supposed to be what? 162? Something like that, just 0.5. That's the section, which is the segment 2. But the thing is,
Yeah.
the distance between where the y-axis and that axis is 0. So there's no point there between it. So it's 0. That's how we get. So we get x2 as 0, but we also get x3 0 because it's the same thing. When you have this drawn down here, and the center of this thing is right here, in the center, which runs straight in where the y-axis runs. This one runs straight where the y-axis is running. So there's no difference between where the center of them lie. They coincide. The center of the figure and the center of the centroidal axis coincide. So therefore, those are 0. Remember, it's a difference you're looking for, you know, to get your x1 and x2. There's no difference. Right? Is that clear? Think you understand what I'm saying
Yeah,
now?
clear enough.
All right, good.
Yes, sir.
Good. So, as a result of that, you're going to apply your standard formula to the first one, standard formula to the second one. However, let me show you now. When you're looking for your section using your formula, let's see if you're looking the correctly. So for this one, your breadth is going to be what? What is the breadth for this one here? Can somebody tell me what's the breadth for this one here? Segment 1, what's the breadth? I want you to identify P
75.
and H. What's the breadth?
75 and 75 and the height is 25.
Come again. I want my breadth and my height. No, you're not correct. Think about it again. Think about it again. Think about it again. Think about it again. I'm gonna write them down again, and I want my breadth and my height for segment 1. But for segment 1, I want my breadth and I want my height. I tend to want to call it depth because I'm used to using those. All right. So what is my breadth, please? For segment 1 again. Can somebody tell me? I'm waiting. What is the breadth for segment 1? This is the figure that I have here. And I know that this is 25. And I know that this is 100. What is the breadth and what is the height? When you're looking in the y direction.
So
When you're
wait.
looking in the
Oh,
y
oh.
direction, what is my breadth and what my height?
100 and the
Yes, so
height
your breadth
25.
is going to be 100. And therefore your
Okay.
height is going to be what?
25.
Yes. Segment 2. I want my breadth and my height. Segment 2 is like this. And I want my breadth and I want my height. I already know that that is 25. And this is what? 325. What is my breadth and what is my height? Segment 3 is like this.
Breadth is 25 and the height 325.
Breadth is 25 and depth is 325.
325.
Right, and this
Okay.
is 100. So this is segment 3. What is my breadth? What is my height? What is my breadth, please?
Breadth is 100 and height is 25.
All right, you guys see the difference we're talking about? Why is that happening so? Because you have orientated the way you're looking. This now becomes your breadth for the first one, and that become your height. Come on again, what is this thing? So all I'm saying here, for this become your breadth, this become your height. So it's become 100 times 25, and of course it's millimeter. I won't bother write those. All right? Well, I could write them just to be here. Those are millimeters. All right? Millimeters, millimeter. All right? They're all millimeters. All right? Millimeters. If they're just hanging off in space, they wouldn't have a value. So it's for the segment 2, it's become your breadth and height. And as such, it changed. So in the formula, don't change. It's just your orientation of how you look at it essentially changes. All right. So let's go through it. So here we have 100 times 25. And this now becomes now, remember you had it. This one was what? B times H. The C says B times 325 cube. And this one now, the last one was 100 for the breadth and the height is 25. So you have it 100 times 25 cube. Now, I already told you that this section is 0, right? So for the first one, only this one alone you can find the parallel axis theorem work. Only the first one, and why? Look, y has a distance between its feet center and the centroidal distance, which was what? 100? I think it was 100. Yeah. See it right there in front of us. 100. See it there? 100 square times 2500. And you will get this value. But remember, you must square the d. If not, you will get it wrong. These two are symmetrical, so it's 0. The ADY is 0. So the parallel axis theorem don't work for those two because they are symmetrical. And therefore, you would simply add these values here, but you have to double this one because it's two of them, and you add them together, right? So that is simply how you do the different axes. So you have x-axis and you have the y-axis. All right. This one is
Wait.
mhm.
So you can go back on the
Let me
previous
go back.
slide where you double,
This one,
yeah, so why you double
we double this one
yeah.
because it's two of them. It's two inertia you need to find right here. Because remember, it's two of these areas you have, you know. You remember, segment 1 have two sections. It have A1 and A1 plus that. And they are same, right? So look, see here, one
So
here and one
A1
over
is
here.
so it,
So you have one here and one over there. So you have to double it.
okay.
Same distance, 100 and
Okay, we
100
get
from them. You see it? You saw that?
yeah, and it okay. Yes, sir,
Right.
yes.
So you would have to definitely do that. All right. So yeah, man. So you'd have to definitely do that. Right. So here, all you do, you would add all of this, and remember, for inertia, this is the important part. You won't have to bother do the area part. You already use the area for the parallel axis theorem here. You're just gonna simply double this and work out the inertia. You're not finding the centroid. You already know the centroid, which is 162.5. That is a estimated centroid axis from here. So in other words, estimate the center where the centroid lie. The centroid drop right here, so midway. So that is why it is symmetrical figure. It's a symmetrical section you have once you have that. So you just double them and that is pretty much it. All right. I am going to give you another exercise and then we discuss it. What time do we have? So I would have given you a problem last time. Can somebody give me the values? And let me just go to a different slide. Can somebody give me the values of the last problem that I put on the board and you were supposed to do it?
Oh, the I-beam.
Yes, the
I-beam.
I-beam. I'm gonna let me just go to a page now where we can look at the I-beam. All right, give me the value of it. I'm gonna draw it. The I-beam, I'm gonna draw it and just give me back the
Fill in the
information.
values.
I just drew one
All
on the
right.
board arbitrarily. Okay, I think one section wasn't equal, eh? Let me. I'm using a new platform here. I'm not.
Yeah, once the bottom section was not equal to the top one.
Right.
Yeah.
Well, I am not able to. This is a new platform that I'm using. Not good in drawing it. I'll try again. All right, so we try to see if I can do a little bit better. There are other people who know how to use it, and I'm just baptizing myself in it. All right, so this is just a sketch. All right, give me the top section again, please.
All right. So there, so we just highlight this. The top part is 100 millimeters across.
Mm-hmm.
The height is 20.
Here, sir.
Yeah. Between there is 160.
Mm-hmm.
The bottom part is another 20 again.
20. All right. Did I
Yeah.
give you the measurement here?
50.
50. All right. So that one was just and as probably millimeter. I don't know if millimeter I was telling
Yeah,
you.
all of that millimeter.
All right. So that is so
The thickness in added for the I-beam is 20 in the center there.
pardon me?
For the 160 length, the thickness here so it's 20.
Oh yes, yes. So it's 20. All
You
right.
get what I'm talking?
Right. So it's 20, it's 20 right around.
But
All right,
and
for thickness. All right, but it actually make
yeah, and the
life
entire
easier
length
when
is
that section
200.
is the same. All right, I was trying to see if I can move. It can't move. All right. Doesn't necessarily trouble us anyway. All right.
All right.
The
1 second there. So the entire length of the I-beam is 200. Or
all
you
right,
can
where did
just
I
work
put
it.
the x-axis? Did I put the x-axis at the bottom? Did I give it?
You never did have one, but me put one at the
Pardon
bottom.
me?
You didn't have any axis there. You just although me did put one, the x-axis at the
At the
bottom.
bottom.
So
You put x-axis at the bottom, right? That's where you put it?
no, yeah, me put it there,
Yeah. All
but
right,
you
fine.
didn't
So you
put
need
you,
to
you did.
is either you could find the centroid from the top or you can find from the bottom. So if you find from the bottom where you call here so x-axis, you're working from some datum point. So I should have really give you a datum point. Let us do something on the board. Right. So if you're working from the top, fine. But we need to find the centroid first. And for this one, I'm gonna just use a straight formula. So you want y bar. So you're gonna find y bar. That's a question. So in order to find y bar, you're going to be using y bar version. So you need the era, the total era times
So wait 1 second.
yes,
So y
someone say
bar is
something.
what the x-axis, another virtual x-axis then.
Another what?
That's y bar, right? The y
Yes,
bar
yes,
is a
yes, yes,
virtual
yes.
y-axis.
Right.
Okay, virtual
Right.
y.
So we're gonna separate it into 3 parts. I'm gonna label them now. All right, so I'm gonna call here so A1. I'm gonna call here so A2, and I'm gonna call here so A3. All right. Now you can actually tell me what you got when you are doing it. All right, so the first thing we need to do is find the centroid, eh? So the centroid here is going to be y bar equals to the sum of all of the individual areas times their respective y2 and y3 divided by area total. All right, so what's your area now for the A1? Let's work out area for A1. So A1 area is going to be 20 times 100. A2 area is going to be 160 times 20. And A3 is going to be 50 times 20. All right. So this is 2000. This one is what now? 3200. And of course, these are what? Millimeters to the square. Millimeters square. And these are going to be 1000 millimeters square. All right. That's what you got, right? And when you sum that, you get A total. What that sum to? That sum to what? Give you 6,200. That's what you got? I didn't work it out. You worked it?
I didn't get to. I was
Pardon me?
attempting to, but I guess you're wrong.
You never attempt it?
No, I was attempting to, but it gets it wrong.
So you got that part right. So the next one, okay, so you didn't get that error. You didn't get that error? Did I multiply something wrong and just checking my values? There's 100 times 20. Do you see any error there? You didn't get anything close to that? All right, next one. So we need now, we have A1, A2. We need to find from the base or the x-axis, we need to identify where the center of it is. For each one of them, we need to identify these distance. The center is halfway where it is. So we need this distance here, y1, and I need y2. I need persons to tell me them, and I need y3. Y3 is this distance here. Y3. Can somebody tell me those distance, please? So I need y1,
So
y2,
A1,
and I will want y3. So I want those distances.
okay.
Everybody.
So Y1 is 100 times 50.
100 times 50, you said?
So that's half.
Y1 is what?
Yeah, that's half 100. Wait,
Look again. It don't look so to me.
wait, 1/2. So wait there.
From the
Oh,
you see where it is
it
from?
is
See your datum point
50
is coming through
times
that
10.
center.
It is 50 times 10.
50 times is no, man. Remember, we just want
Oh, wait,
a
not
y
this
value,
one.
you know, going up to that point, you know. Why? You see my arrow? You see the distance? I draw it already for you. Just identify it. Look. Are you seeing what I'm doing? You see what I'm saying? So all I'm saying here, it is the distance to the center. Where's your y1? So it's the base, from the base of the figure going right up to there. Can you see the difference? You want this distance here. Look, it's that distance I want from, you know, y1 to the center of that figure right there. What is that one? I'm waiting. And I want this one also. From there, from the datum point. The datum point is down here, is x-axis. So I'm waiting on those. I want all three of them. One y1, y2, and y3.
So Y1 is 190 millimeters.
Is what?
190.
All right, let's check it. All right, because halfway of this is 10. Half of 20 is 10. We have 160, and we have 20 here, so that gives us 180 plus 10. So you see it? So this is 10. Then from here to down here is 160. And from here to down here is 20. So you get how much did you say? 190. All right, that look like you're in business. Next one.
100.
100? Can you tell them how you get that?
Half of 160
Uh-huh.
plus the 20.
So half of 160 is 80, plus the 20, you get 100. All right. That writing is kind of half scale. Let me just go again. So this was 190 millimeter. This is 100 millimeter. Y3.
10.
All right. All right. So therefore, I want everybody now apply that formula and see if you can get the Y. So calculate Y bar for me. Exercise time. Y bar, everybody. All the participants, calculate Y bar for me, please. So therefore, at the end, you'll be able to tell me what to write and what the calculation is. So I can help you by just putting some stuff in. I'll put some stuff in while you're tinkering with it. So we know area one is, what was area one again? Area one is 2000. So that's 2000. So you just need to put in area one is 2000 times y1 was what? 190 plus area two, 1000. No, area two. Actually, all right, I'm not going any further. Apply that formula and see if you can get it right.
Y bar is
How much?
13,700.
How much?
13,670.
No, man. You couldn't get the Y
Our
bar
then.
for that value. No way, man. How you forget it for that value?
Yes, I multiply the area times
No,
y1.
man. Come. All right. So for the second part, area two was what again? 3,200. So it's 3,200 times y2. Y2 was what again? Y2 was 100. All right. Let me do a little clean up here. Something it's not moving. What is this? All right. I have to go work with it. All right. Plus, area 3 is what now? What was area 3? Area 3 look like 1,000. Times and y3 is what? 10. When you work out that, that's what you got?
Oh, just the top part, yeah. And then maybe supposed to divide it. Oh, my
Yes. If you work them out individually and make one go, you should get a value that is representative of y bar. Even, I mean, it is a problem that I just take out, I just took it out at midway, but it should still give you a value. Reasonable, I'm thinking. That's the only catch to it that I just took it out of mid-year.
I got 2.204. Well,
Hold on,
2.205.
How much you say I got?
2.205.
Come again, man. Check that. I am getting 59.35. You didn't get anything like that? Millimeter. Which is telling you that Y bar is somewhere, probably somewhere down here. From that now, I wanted to try and find the inertia for this figure for me. So I want you to work out the inertia. I won't be working out this one. When you finish work it out, you can scan it and send to me. Let me post it and see it. So work it out now. When you finish, just send it in the you can WhatsApp it to me directly, and I will just look at it to see the approach. Work it out on a paper. All right. And we look through them until we find the right workout. Right, work it out right now, WhatsApp it to me, and I will we'll look at it to see which one is the correct approach. And then that will wrap up things. So I've worked all of this problem now, it's your time. So I work the Y bar. You're going to find the inertia, the first part, second part, third part. And so the hardest part you have is to identify your individual DY. So you're gonna find your DY for the first part, DY for the second, DY for the third. All right, those are, once you're able to find, in fact, tell you what, work out those and bring back to me next week. Make sure you have that. You can send it to me as a WhatsApp individually. Let me look at them. Or I can send you an email and you email it to me. Which one you prefer? You want an email? I have to stop now. You want to give you an email and you email it to me? I'm not hearing you now.
Sir, we WhatsApp it to you.
All right, fine. All right, that's it, because I'm kind of tired right now. We'll take a break. Now let's work that one out for me and see if you're understanding IB. So your hardest task now is to find your DY. Right? Once you find your DY, I already find this for you, you know. So you're gonna work around this same distance that you have here now. All right, for all of them. All right, so I will see you next class. All right, so that's end for me today. You all think you understand and grasping the topic? Can I get a yes? What is it? Think that you're understanding?
A
Pardon me?
little bit, but yeah.
Pardon me?
You grasp it. Yes, sir.
What?
Yes, sir.
Okay. All right. Good. All right. Good. All right. So that's it for me. I'm out.